Welcome to another Solidworks video for Ivy Tech Community College. And in this video, we're going to be working on a multi-session project, which you can see here. We're going to be eventually creating this entire water control valve, but we're going to break it down into two separate sessions. So for the first part, for what we're going to work on together right now, I'm going to show you how to build these two housings for the valve. And then we're actually not going to model every single piece in here. When we finish the valve, I'm going to give you all of these little smaller, what I would call the guts of the valve, all these little smaller knick-knack pieces. We're not going to model every single one of these because what I want to do in this one is spend more time on looking at how to assemble pieces. So for the first session for today, I'm going to show you how to model this piece and this piece, kind of the two main flanges or pipe sections for the valve. And then in our next video later on, we're going to look at how to take all these pieces after I give them to you and how to insert them in here and constrain them all. So for today, we're going to look at these two pieces, and we're going to do something a little bit different. We're going to look at actually modeling the parts inside of an assembly file, and that gives us a little bit of an advantage where you can notice that this housing and this housing are similar. They're not identical, but they share some similarities in these flanges. So instead of modeling these two pieces completely from scratch, we're going to model them inside of an assembly file. And what that allows me to do is it allows me to kind of reference geometry from one part to another. So this is a trick that we haven't used a lot, but it will save you a lot of time. So we're going to model this piece first, and after we do that, you'll see how we can kind of reference or convert sections of this model into the other one to speed up the modeling process. So I can sort of make this part match parametrically this one in the back. So that's one of the advantages of doing things in an assembly or modeling your parts within the context of an assembly file, is that it allows you to draw less and create more parametric relationships between the parts. So let's go ahead and get started on this first piece. I've got the textbook open. This comes from chapter 19 of your textbook. So we're going to work through basically 23 pages in the textbook, but it's not going to take as long as you might think. We're going to look at some shortcuts and ways to speed things up. So I'm going to go to New, and contrary to what you're used to, we're not going to make a new part, we're going to make a new assembly. So remember, we're going to be modeling these parts within the context of an assembly. So I'm going to make my new assembly, and instead of where you would normally throw parts into here, we haven't modeled any parts yet, so I'm just going to close this out, which is a little bit opposite of what you're used to probably. And these parts are all going to be in inches. So down here, make sure that the units for your drawing or for your assembly are set on inch, pound, second. And so make sure you're in the US customary system, not the metric system. And what we're going to do is we're going to go ahead and jump into our first part. So normally where you would insert components or insert parts that you had already modeled up here, we're just going to go to New Part, and we're going to do kind of what I call modeling parts on the fly. So you're basically building this assembly and you're building the pieces or the parts as you need them. So I'm going to make a new part, and I'm going to reference that based on the front plane. So I'll hit that. And there's a really nice option in here that I like that we haven't used yet. So I want to show you how to turn it on. There's an option in Solidworks where you can have Solidworks rotate to your sketch plane automatically anytime you create a new sketch. And if you've used Autodesk Inventor at all, you know that that's a function or a feature that Autodesk Inventor has where it will automatically rotate to things. So to make that happen, if I go to Options, you can go to your Sketch tab and turn this box on. Okay, so highlight that box or make sure it's checked, and then just exit out of that menu and make sure that those changes were saved. But now you'll see what it does is anytime I make a new sketch on a sketch plane, it will not only start that sketch, but it will automatically rotate it. So that saves you the step of having to do this every time and bring up this view box where you can choose the correct view to rotate to that drawing plane. So I really like this option because it saves you that annoying step of having to hit Control Spacebar constantly every time you make a new sketch. So just one more little trick for you there to kind of speed things up and make your life one step less frustrating. Okay, so what I'm going to do on this sketch is I'm going to start by drawing out a center line. So we've used our center line tool a lot, and we're going to use it right here. And when I sketch this plane, or when I sketch this cross section rather, we're going to end up using this for a revolve. So I'm going to sketch out a bunch of geometry up here, but none of it is going to touch the center line. I'm just using this center line as the basis for my revolve. So I'm going to go ahead and grab my regular line tool, and I'm going to sketch out a profile and try and keep it in line with the origin, but not touching. And it's going to look sort of like this. So try to get it, fairly close. And they give an example of this in your textbook. So you won't get it perfect the first time, but just try and get it, fairly close, where it looks reasonably similar. Okay, so something sort of like that. Now I'm going to jump into my dimension tool and put some dimensions on this. And the textbook mentions that as you put these dimensions on, if you dimension to the center line, it will give you the virtual diameter. Mine doesn't do that, so I'm just going to sort of find a workaround here. And in the book, they've given me this as a dimension of 2, so I'm just going to do 2 and cut it in half, since mine is dimensioning the radius instead of the diameter. So I'm just going to take all the dimensions they give me in the book and just cut those in half, instead of trying to do it, on pencil paper or calculator. So this they say is 2.7, so I'll divide that by 2, giving me 1.35. This dimension they tell me is 3.75, so I'll cut that in half to get the correct number. I know that right here I should have an angle of 45 degrees, so we'll go ahead and label that. The thickness of this section should be 63 thousandths, so 0.063. I've got a dimension horizontally here across the whole part of 2.125. I won't cut that one in half because it has nothing to do with the revolve command. And you can see my sketch is getting a little out of whack here, so if this happens, just hit escape a couple times and grab your lines and drag them back where you want them. So don't let that intimidate you. And then I'll run a dimension from here to here. That's going to be 1.375. And next we're going to have an angle of 12 degrees from here. I'm just going to run it to this line. You could run it to the center line also if you wanted, but it should be the same either way. We're going to have a distance on the top up here of 0.65. This angle should also be 45. The distance of this section horizontally should be 63 thousandths also. The height from here to here should be 3. And finally, I need to give a location for one of these points, so I'm going to dimension from this bottom point. This might be a tricky measurement to get in there. I'm going to dimension from this point to this point. And they say 3.625 in the book, so I'm going to cut that in half. Okay, so there's our first profile. And again, don't worry about your dimensions too much here. No one's ever going to see these. So if we put these on a drawing page, we could clean them up at that point. So what I have done here is absolutely horrible dimensioning practice. Everything's overlapping. They're crossing over wrong. But this is just for modeling. No one's really ever going to see these. If you wanted to clean them up a little bit in case you need to come back in here and edit this file someday, that might not be a bad idea. But remember, these dimensions are not necessarily going to be viewed by someone on a drawing page. They're really for the modeler to use. So I'll clean them up a little bit, but don't stress about them too much. Okay, so I'll back out of this, and I'm ready to do my revolve now. So I'm going to go to my Features tab and do a Revolve the Boss Base feature. Choose my profile, and Solidworks will automatically pick up the center line, or hopefully, and I'll just OK that. And there's kind of the backbone for our first piece. So the next thing that I'm going to do is sketch the flange on this face where the bolts are going to go through. So here is where you'll notice whether your auto rotate for your sketch is turned on or not. When I make a new sketch on this face, you can see how mine automatically rotates. That's a feature that I really love. So if yours didn't do that, make sure you go back in here to options and turn that option on in the sketch section. But that's a feature or a setting that you're really going to like. It's going to save you a lot of time. Now this I'm going to draw differently than the way they describe in the textbook because I think they overcomplicate it in the textbook. In the textbook, they want you to turn on the dynamic mirroring feature, where as you draw, it will automatically mirror the drawing. I'm not a huge fan of that. I find it to be kind of distracting and a little bit hard to use. So what I'm going to do is just sketch in some center lines through this circle. And the way that I came up with to do this, I think is a little bit easier. Maybe I'm biased, but I'm just going to draw some center lines through this part. And actually, before we do that, let's take this face and just convert that into the drawing. Now I can draw my center lines right on there. So you may want to convert that outside circle and convert the entities on it so that it becomes part of your drawing. But I'm just going to draw center lines from top to bottom through the middle of the circle. There we go, looking perfect. Okay, so the next thing that I'm going to do is draw a circle. So I'm going to draw a circle. The size that they give me is a radius of 2.5. So I'll just draw a circle and dimension it, and I'm going to say that a radius of 2.5 would be a diameter of 5. So I'll dimension it as a diameter of 5. And at this point, I'm going to go ahead and draw a rectangle now. So I'm going to use my rectangle tool, but I'm going to use the center rectangle tool, not the corner rectangle that we're used to. So I'm going to drop this down and get my center rectangle tool, and I'm going to start right at the middle of the circle and just kind of draw out a rectangle out to here. Before I do anything else to that, I'm going to make a relation between the edges of this and say that they have to be equal, or in other words, I'm going to lock it in to where it's always a square. Okay, now eventually that thing is going to sit sort of right here, so I'm going to dimension that. And I'm going to dimension from the center line over to here, and I'm going to say that distance is 1.575 plus 0.787, just because of the way they gave me the dimensions in your textbook. Okay, or if you want to look at it as another number, you'd say 2.362 is that size. So we've got a square basically that is 2.362 from the center line to the edge. Okay, and you can see this is starting to become kind of a mess with all these center lines and dimensions. So try to keep your sanity as we do this drawing, but the next thing that I'm going to do is start trimming some things out. So I'm actually going to take this circle that I converted in the back and delete it because I don't really want it to be part of the drawing. And then I'm going to pick these center lines, for instance, and make them vertical. And we have something here that's not constrained. Okay, we're not locked into the center point, so let's just take this point and the origin, and we're going to put a constraint on those and say those are coincident. Okay, so that fixes that. So take that outside circle that we converted, delete it, and make sure your center point for your rectangle is locked into the center of your part. And you should know because your sketch should be completely black at this point, it should be constrained. So now I'm going to take the trim tool and kind of work my way around, and what I'm going to do is trim off this piece on the circle and this piece on the square. And I'm just going to work my way around here. So I make this weird overlapping shape where part of it's a circle and part of it's a square. So notice on the corners I keep the rectangle, and then on the sides I keep the square. Or sorry, I keep the circle. And if you mess it up like I did, just do an undo. You can go right back in there and try it again. It's very easy to accidentally trim the wrong thing. And thankfully it's pretty easy to fix as well. Okay, so you'll notice here that I've broken a constraint because things have started to turn blue again. So if you take the blue lines and drag them around, you can see what's going on. So in this case, there's two ways I could fix this. I could force this line to be 45 degrees, or I could also say that this line and this line have to be equal in length, which would force this to be 45 degrees. The equals constraint is a little bit more easily understood to me, so I'm going to say these two lines have to be equal in length, and that locks everything back in. Okay, so the only other thing I need to do at this point is round off these corners and then round off all the intersections. So I'm going to go to my fillet tool, and the first size that I'm going to use on this is going to be a radius of 0.787, and I'm just going to work my way around all these corners. Okay, and you're going to get these messages. Just hit yes. Okay, it's just asking you about constraints because it's not sure how you want it to put the fillets in there. So if it pops up and asks you, just say yes. Okay, so we're going to put in those 4 fillets at 0.787 on each of the corners. So we'll OK that. And now I'm going to go right back into my fillet tool, And this time I'm going to use a different size. I'm going to use a size of 1. And what I'm going to pick up now is all of these sections, and you're going to have to hit yes a bunch here again, but I'm going to pick up all these sections to try and smooth out these transitions to these arcs. And there should be 8 of them total. So try and get them all at the same time, and you can count them when you're done to make sure you got all of them. But they should turn yellow to kind of highlight and let you know that you're getting them all. And you'll get what I call the nastygrams, where it pops up and asks you questions. Okay, so there's all 8 of those at a size of 1. So I'll just hit OK there. And you have quite a sketch here now. You can see this is a crazy number of relations. So you might want to go in here to the sunglasses and temporarily turn those things off, so you can kind of see what's going on if it bothers you. So you can go in here and turn relations off if you need to. But as soon as you exit this sketch, they're going to disappear. So now we're ready to go ahead and extrude this thing out. So I'm going to back out of this sketch and go to Features and Extrude. And make sure that you choose the hole in the middle as well here so that it does not get filled in. So there is my selected contour, and my total depth for this is going to be 0.65 inches. And we'll hit OK. And there we've got the basic geometry for this part. So the next thing that we're going to do is kind of work our way around here, and we're going to put the mounting holes in this front face in this pipe flange. So I'm going to rotate around and pick this section and go into a sketch. And on this one, I'm going to start by just drawing in some center lines. So I'm going to draw a center line right up off of the middle here. And then I'm going to draw another one kind of out here at an angle. I'm going to make sure it hits the outside of this circle. So somewhere out there. Now I'm going to dimension between those, and I'm going to say that I always have to have 45 degrees between those. So I'll just put in 45 degrees. And now I need one more thing to locate these circles. I'm going to put a circle in here that I can use as a bolt pattern. So I'm just going to draw a circle in here, and I'm going to say that's for construction to turn it into a center line. I'll just hit OK, and now I can dimension it. So the size for that is going to be 4.75 inches. Now I have a point where I can put my first circle, so it should go right here. So for starters, I'm just going to draw the circle out here, and then I'm going to use my constraints to choose that point and this circle, and I'm going to say those need to be coincident, not concentric, but coincident. I'm going to pick this point and the line and say now that this circle also has to be coincident with that line. And what that's going to do is lock it into both this bolt pattern, or this bolt circle, and this line. Now I can just dimension the diameter of the circle, and it should be 3/4 of an inch, so I'll say 0.750, and there's our first bolt hole. Now I could do that again several more times, but that's going to take a while. So you have options now. You could mirror these if you want, or you could do a circular pattern. I like the circular pattern, so that's how I'm going to do it, but you could also mirror that twice and get the other 3 holes. So for the entities to pattern, after I choose my circular pattern, the entities that I want to pattern are this circle, and it automatically assumes 4. You could adjust that here if you want more or less. And so I'm going to hit OK. And now I'm going to go ahead and put some constraints on these. So you can see how it doesn't really assume the size here. There are ways you can fix that, I believe, as you put this in. So if I were to put some dimensions in here, like let's say I go back in this menu, I could put the dimension radius checkbox on. That helps a little bit as far as locking things in. But what I'm going to do also is if I just drag these off of the edge, I can grab this center point and this circle and say that those are coincident, and that helps to lock everything in too. So you still probably have to lock in the center point for some of these other circles, just with a relation. So I'm going to back out and cut these out now. So I'll go to my Features tab, Extruded Cut, pick this circle, and then come down to Selected Contours and pick the other ones. So we should have 3 of them total. You can either pick the edges or the closed sections here in the middle. Either one will work. And instead of a blind extrusion, I'm just going to say up to next. And what that's going to do is basically cut through to the next surface, which is right here. And I'll hit OK. And there is our first set of holes that we've cut out. Now if I rotate around here, we're going to do basically the same thing on this face, but the textbook I think really overcomplicates this part. What they have you do is they have you go here and make another sketch, and they have you basically repeat the entire process again of drawing the two center lines and the bolt circle, and then putting the circles in and patterning them, when I think that there's a lot easier way to do this. So what I'm going to do is the size for these bolt holes is exactly the same on this flange as it is on this flange. The holes are just a little bit smaller, but the locations are in the same places. So instead of trying to locate all those holes again, I'm just going to go to Convert Entities and pick these circles in the back of the other flange and bring those into my sketch. Okay, so let's go Convert Entities. There we go. So I'm just going to choose these holes. Okay, so you're going to convert those entities, and don't choose the surfaces like I did at the beginning. Choose the front face and bring those on through. So now I know where those holes are supposed to go. So at this point, what I can do is just draw my smaller size circles right on top of them, and I already have the spacing in the right place. So I'm just going to draw one more here, 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 and here. I'm going to make those all equal to each other. So I'll choose all four of them and put an equals constraint, and then I can just dimension one of them. So I'm going to pick this one and say that it is a diameter of 0.525. Okay, I'm just going to leave the other ones in there. So what that's going to do is this sketch will always control this one. So wherever these center points on these holes are at, these ones are going to follow. Now, if you didn't want the part to behave that way, obviously this wouldn't be a good way to model it. But in my case, I'm perfectly fine with the center of these circles following the ones in the back on the other flange. So I'm going to use that as my method when I model this, instead of trying to sketch it all out another time when the dimensions are exactly the same. So I'm going to go to my Features tab, go back into an extruded cut, and you have to be careful here because it's going to choose probably something other than what you want. So you can see what mine is choosing here. So I'm going to come down to my contours and delete that out, or maybe just back out of the whole thing one time, and then go back into an extruded cut, and you can actually pick which sections you want. So I'm going to choose all of the smaller sections because these holes are supposed to be smaller, so watch out for this. But then I'll just hit OK after I set this to up to next, and there you go. So there we have our two flanges from our revolve and our extrude. We put the four holes on each side. So now what we're going to do is just kind of smooth the part out and pretty it up a little bit. So I'm going to jump into my chamfer tool, and we're going to put in some chamfers at a size of 0.32, and we're going to chamfer all 8 of the holes and then both sides on this round flange. So I'm going to pick around the outside, so you can pick the edge of this flange basically, or this side surface, and it will pick both corners. And you can use the same trick on the holes. So if I pick the inside of this hole, notice that it picks both edges. So it's a little bit faster than trying to go around and pick all these. So it's a nice shortcut to kind of speed things up. So we're going to pick all 8 holes using this trick, and then the 2 edges of the round pipe flange. And again, the size is 32 thousandths. It's a 45-degree chamfer. So we'll just OK that, kind of break all those sharp edges. And now we're going to put in a couple of fillets. So I'm going to go to the fillet tool, and we're going to use a size of 60 thousandths. And the 3 edges that we're going to fillet are right here. So basically where this thing transitions. So there, there, and there. So these won't show up very well. They're not terribly large, but it would help to smooth the part out a little bit. Now we're going to go put a couple more chamfers on. So we're going to go back to our chamfer tool. This time we're going to use a size of 1/8 of an inch. So I'm going to say 0.125. And we're going to chamfer both of these holes on the pipe section that goes through the middle. So I'm just going to click this surface right here. You'll notice it picks both sides. I can hit OK. And now you can kind of inspect the part. So at that point, this first part is done. And remember, I've done all of this inside of an assembly file. So what I'm actually doing here is I'm in the part menu inside of the assembly menu. So now that I'm done with this part, I want to go back to my assembly environment. So I'm just going to hit this button to exit editing this component. You could also hit this, does the exact same thing. So I'm just going to go back. So now I'm in my regular old assembly environment, kind of where I started, but I've also edited or created a part here. Now, you'll notice when I made this part, it gave it its own name. So it automatically named this thing Part 2 of Assembly 2, which may not necessarily be what I want. I'd like to give this a more descriptive name. So I'm going to right-click this part, and if I go down, I guess up to here, I'm going to say Rename Part, and I can give that a new name. So let's call this, they say to call it Outlet Housing. So I'll just rename that and hit Enter. And then I'll go to File, Save As, and let's just save this thing somewhere. So I'll just put it on my desktop for right now, or you could put it on your flash drive. And let's just call this Water Control Valve. So we're going to save this assembly as the water control valve. And it's going to pop up with this, and you're going to say Save Internally or inside the assembly, hit OK. Okay, and there we go. All right, so my feature tree is glitching out a little bit here, so I'm going to go ahead and pause the video and restart this. For some reason, we're being a little glitchy here. There we go. Never mind. Just drag that out. Okay, so now we're ready to start our next part here. So we're going to make the second part now inside the assembly file still. So we're going to go and create a new part, but we're going to add the part that kind of meshes into this. So you're going to see as we do this the advantage of creating these parts together in the same assembly file, because it's going to allow me to reference from one part to the other. So as we create this second part, now I can steal measurements or geometry from the first part and use them to create the second. And I can create that parametric relationship between those two parts. And that's going to save me the step of having to remodel a very similar piece from scratch, basically. So I can take work that I've already done, pull it into another part, and then the other nice thing is you can make sure as you're assembling the parts, you're modeling them at the same time, so you know that the measurements and the dimensions are all correct, and you know that the parts match up the way that they're supposed to. So we're going to go ahead now and create our second part. So up here in Insert Components, I'm going to drop that down and just go to New Part. So we're creating a part file inside of an assembly, remember, and it's asking me kind of for a reference plane as I create this. So I'm going to click on this face right here, and you'll notice the existing part that we already had is going to turn into kind of a wireframe setting. And what I'm going to do is steal some of the geometry off of this one and bring it into my sketch. So I'm going to basically click this section and right click it, and I'm just going to go to Select Tangency. That's going to select the whole outer edge of this flange. I'm also going to Control click and pick the inside of all these holes. So make sure you don't pick the chamfer, but you actually get the through hole that's in the middle. And this can be kind of tricky, so make sure you're clicking the right thing here. Okay, so we have all that selected, and remember I'm already automatically in a sketch here when I create this new part. Once you tell Solidworks which face you want to create the new part based on, it automatically pulls you into a sketch. So after I select those different edges, I can just go to Convert Entities, and now if you want, you can come over here also, and here's my first piece, Outlet Housing. I can go up here and hide that component, so this shows me just what I'm making that's new, or I can also come up here and turn it back on, and there is the existing piece also. So it's helpful sometimes, I think, to toggle these pieces on and off, the visibility, and you can tell by this icon right here whether the part is set to be visible or hidden. So sometimes I like to hide those parts in the back so I can really see what I'm doing, and it's difficult sometimes to tell what you're doing when that part is in the background. But notice I can get all of this geometry and I don't have to sketch any of it. And the nice thing is that this one will always match the other part. So if I make any changes to the first part, the second part will always match it. So I'm going to go ahead and back out of this sketch, and I'm going to go to my Features tab and just go to Extrude. And I'm just going to choose this profile and come down to Selected Contours and choose the edges of all these circles so that they don't get filled in when I extrude it. And if we look, the depth for this extrusion is supposed to be 0.650. So I'll put that in and OK it. And there we go. Now I can actually go back here since I've kind of got some more geometry. I'm going to turn that piece back on so we can kind of see how these match up to one another. Okay, so this is kind of the advantage of doing this. It saves you a lot of work. Okay, so the next thing that I'm going to do is I'm going to make a sketch on the right plane of this part. So I'm going to go to my sketch tab and do a new sketch, and it asks me what I want to sketch on. I want to sketch on the right plane of part 2, which is going to be right here. So I'm going to choose that, and I'm going to rotate around here a little differently. I'm going to draw it from this orientation so it matches what the textbook is giving me. And I'm just going to draw a center line off of the origin here, just out to some distance, maybe about there. And now I'm going to draw another cross-section profile that I can turn into a revolve. And I'm going to draw it off of the center line, just like we did the first time. So looking at this, I'm going to start about right here. No, sorry, about down here. So probably about right there. I'm going to come out this way, down, over, angle a little bit, and then come back kind of to here, and then straight up to where I started. Okay, and you can kind of see they're saying we need a tangent constraint here. There is supposed to be an arc in here also. So let's see if we can do this a little differently. If I actually, this can be kind of tricky to sketch. Let's leave that out for right now and see if we can actually fillet these lines. I'm not sure if it's going to let me do this, but let's try it. If I do a fillet of 2 between here and here, yeah, it's not going to like that. So what we're going to need is a little straight line segment right here. And now see if we can fillet that at a size of 2. That's more like what we're looking for. And then I'm just going to take this and kind of drag it back over here, because we should have a little tiny straight line segment there the way that this is drawn. Something kind of like that. Okay, so now I'm going to get my dimension tool and start locking this stuff in. This section here is supposed to be 0.62, but they have that as a reference dimension, so maybe let's leave that off for right now. They have that in parentheses. We can do the angle between here and here. This should be 15 degrees. My distance from here to here should be 1. My distance from here to here should be 1.5. My distance all the way down to the bottom, you may have to zoom in to get that one. From here to here, that should be 2. Okay, and other dimensions we're missing, we need the total width. So I'm going to go from here down to here. And that we're saying is 2.75. And then we need a dimension. That looks like everything, so let's see how we're not constrained here. We do need that, so they're listing that as a reference dimension, but it really shouldn't be. To me, it's going to define this shape, so I'm going to say that this dimension should be 0.62, and although they have that in parentheses, I would not say that that's a reference dimension. It's needed to define the sketch. Okay, so there is our sketch for this part. So we're going to back out and we're going to do a revolve. So I'll back out of my sketch. I'm going to go to Features and choose Revolved Boss Base. My axis of revolution should be my center line, so it's got that picked. That's good. And my selected contours should be this sketch, so that looks good. We'll go ahead and OK that. And there we're getting a little bit farther in this part. So the next thing that we're going to do is go ahead and sketch on this face. So I'm going to choose this face and go right to a new sketch. Notice that it rotates to match to that face. And on this part, I'm going to sketch another flange that matches this. But instead of redoing all of this again another time, I'm just going to use my convert entities trick to save myself a bunch of work here. So I'm going to pick this edge and the inside of all these holes. So watch out for the chamfers here, because you don't want to pick the chamfer, you actually want to pick the through holes on all these parts. So let's try this again. It can be kind of tricky to pick all these things sometimes. Sometimes you have to rotate around to where it'll give you what you want. This one's being especially stubborn. Okay, and then I'd like to get the through hole on this if I could, although I could just use this and bring that into my sketch. So let's do that. Let's take all those options and convert them in. So there you can see I've basically got the flange sketched out already, and it will always match this. So I don't have to dimension anything or draw anything. I can just back out of that sketch now, and I can go ahead and extrude it out. So I'm going to go to extruded boss base. It's going to pick all those edges. We're going to say 0.65, hit OK. So that's a really quick, easy way you can get that in there, and now it will always match this one. Okay, notice I haven't chamfered any of these things yet though. So the next thing that I'm going to do is put a pipe section up here that comes off of this transition that I can use to put a flange. So we're going to put in a reference plane. So I'm going to go to Reference Geometry and Plane, and we're going to do an offset plane. So my reference is going to be the top plane of this part. So I'm going to pick the top plane as my reference, and my distance is going to be 1.625 inches. Okay, up towards the top, so we'll hit OK. And now we're going to take that and we're going to sketch on that plane. So I'm going to choose that plane that I just created, and we're going to do a sketch on it. Okay, so you'll see that it rotates around, and now what I can do is sketch a circle on here. And that circle, we want to be lined up with the origin, and it's going to be about right here somewhere. So I'm going to dimension that to start with, and its overall diameter should be 1.50. I want to make sure that that's always locked in with the origin, so I'm going to pick that point and the origin and say they should be vertical. So they're vertically aligned with each other. And then off of the origin, I want it to be exactly 1 inch away. So I'm going to dimension from here to here and say that distance should be 1. Okay, you can see how that kind of overlaps. It's a little bit of a weird transition, but it actually should cut into this flange according to what they tell you in the textbook. So I'm going to back out, and we're going to go ahead and do another extrude. So I'm going to go to Features, Extruded Boss Base. I'm going to pick that profile, and we're going to extrude it out 0.875 and hit OK. And like I said, this is going to look a little bit weird right here. Probably in reality, if you were going to design a part like this, you would move this section down here, but that's what they've shown in the textbook, so that's what we're going to do. To me, it would make more sense to move this down and get it out of the flange, but we're not designing the part, we're just creating it, so we're just kind of following their instructions here. So now we're going to put a pipe flange on here, so I'm going to pick this section, and we're going to do a new sketch right on top of there. And the next thing that we're going to do is kind of convert some entities here. So what I'm going to do is, before I convert, I'm just going to draw a circle on here. Another one up here that's concentric with one more. And I'm going to draw a center line. So I'm going to try and make some symmetry here. And I'm just going to draw a line that connects from here to here. Okay, so I'm going to say that this and this have to be tangent. So we're going to start doing some constraints here. These two need to be tangent. These two need to be tangent. And these two need to be tangent. Okay, and before I go any farther, I'm going to dimension my circles. So this outside one we see, well, let's go ahead and extend them so we can trim them off and dimension them the right way. So I am going to go ahead and extend these. So let's extend that one. That needs extended, this one needs trimmed, and that one needs trimmed. So I'm going to grab my trim tool, zoom way in here and trim that off. Come over here and do the same thing. I'm going to trim off this section and this section. I'm going to take this one, and we're going to leave that for right now. We'll end up extruding that cut out. So now I can put some dimensions on. So now we're going to say that this large size at the top should be a radius of 0.5. And the small one inside of there should be a diameter of 0.38. And I'm going to say I want this to be vertical with that center line, which it's not liking, so let's see what we can do here. If we can drag this around, let's do an undo. Let's try drawing another center line in there instead. It seems like it would let you do the vertical constraint, but in this case it doesn't want to. So I'm just going to draw another center line and say that and that need to be coincident. That takes care of the same thing. And now I can put my spacing on there of 1.32 from here to here. Just kind of pull that in. And this section right here should be a size of 0.95. So that should have a radius of 0.95. And what I'm going to do now is just trim off the bottom of this circle. And then I'm going to take everything up here on the top and mirror it down. So carefully pick all of your geometry up here. And then I'm going to do a mirror. And my mirror line is going to be this horizontal center line. I'll hit OK. And there is our pipe flange, if we've drawn that correctly. So we'll go ahead and hit OK on that. And then we're going to extrude that out 1/4 inch. So I'm going to go to extrusion, make sure the holes are working, which it looks like they are, and our depth there is going to be 0.25. Hit OK. It's not liking something there. Let's see our contours again. There we go. Accidentally selected the merge result, so I didn't want that. So let's go back and uncheck that. Okay, we actually need to merge this in 2 directions. So notice how we have a little bit of a gap in there. That would be hard to create and kind of strange. So what they want us to do actually is take this flange and wrap it down. So I'm going to go back into that and just go to Edit Feature. When I did that extrude, so I'm going to go in here, go to Edit Feature, and I'm going to do a second direction on this. But my second direction, I'm going to go, instead of blind, I'm going to choose Merge Result, but in the other direction, I'm going to choose Up to Surface. And the surface that I'm going to pick is this top face right here. Okay, so we'll go ahead and hit that. And now you can see how it takes it down and kind of wraps it into this face. So this is a really weird way, in my opinion, to design this part. It would be much easier if you just pulled this pipe section down and had it cleanly go into the middle of the fitting. Also, they're going to have a really hard time on this of getting these 2 fasteners in here. So whoever designed this really was not planning ahead. They're also probably not going to be able to get a fastener in here because there's not enough room for it right here. So, you know, it's not a real life scenario necessarily, but it gives us a chance to model some parts. So in real life, this thing probably would not work. You wouldn't be able to get a fastener in there. There's just not enough room. And same thing here. And even if you could, it's going to become impossible to tighten the things. So, you know, we're just practicing the modeling here, but as far as actual real life effectiveness, this is a horribly designed part in my opinion. So now what we're going to do is, since we've got kind of our extrusions done and we've got the main features built, we're going to put a hole in the top here. So I'm going to click on this face and just do a quick easy sketch. So thankfully this is a pretty easy one. We're just going to put a hole right in the middle of this thing. So I'm just going to kind of track off of these other features right there and put a hole. And we're going to say the size on this is a diameter of 1. And I'm going to say that this and this arc maybe have to be concentric, just to lock it down. Okay, so we'll back out of the sketch. We're going to go to an extruded cut. And we're going to go up to next. And they say to hit the reverse direction button, but I don't see that that's necessary. So we're just going to go up to next, hit OK. And there we've cut that hole out that kind of wraps through everything in there. So we have a nice hole now that comes through from that other section. Okay, now we're just going to do what I call kind of prettying up the part. So we're going to put in some fillets. So I'm going to go to fillet, and these first fillets are going to be 80 thousandths. So 0.080. And we're going to pick 5 edges. We're going to pick this section here, if we can choose our items to fillet. And unfortunately, that's going to further complicate our problem of trying to fit a fastener in there. And for some reason, it's not liking that. Let's try some of these other ones. So there we go. There's that one. We're going to pick that one. Now it's letting me pick that one. So that's 3. Now we're going to pick this section here. these little guys here. It looks like we have everything there, but I'm not confident this is going to work because it looks like it's going to give me an error message. But let's go ahead and see what happens. Yeah, that's what I was afraid of. It doesn't look like it likes this. So let's back out and try this one more time. Mine's just acting very weird in general here. It just doesn't like this section up here. So I think we're just going to leave that one off for simplicity's sake. So remember, these fillets are just to pretty things up. And I think we all, at this point, know how to put a fillet into a part. But for some reason, the sizes they've given on this part do not allow it to be filleted. And for some reason, mine's just not even working at all. It won't even let me select the lines. So let's try rebuilding this part and saving it. So I like to leave these frustrations in here sometimes so you guys can kind of see how to work around them, although there's not always a fix. So my next step at this point would probably be to just close the part and reopen it. But it just does not like this section right here. And it may be that I'm missing a constraint there possibly, but I kind of doubt it. So I'm just going to put these two in because the other ones, it's not letting me. I may come back and try them later. Okay, let's put some chamfers in. So we're going to do chamfers of 32 thousandths. And on this one, they say we're going to chamfer basically all of the holes. So I'm going to pick all these new holes that we created and the outside face of this. We're going to chamfer the upper edge of that. And then also this hole here and this hole here. Okay, that looks good. We'll go ahead and OK that. Now we're going to go right back into the chamfer tool, and we're going to pick some chamfers that are 1/8 of an inch, and we're going to pick this hole again. You can see that it picks up the edges there. It doesn't want us to do this edge that's on the inside, so I'm going to see if I can control click and remove that. We may have to pick these the hard way if we go kind of here and here. Okay, so don't pick the inside hole here. That one's not supposed to be chamfered. So we'll hit OK on those two. And at this point, we've got that part done. So I'm going to save for just a second here and see if I can figure out what is going on right here. And if I'm able to fix it, I'll come back and let you know. But if not, we'll just pick up and move on. So I'm going to pause the video and see if I can figure out what on earth is going up with this fillet right here and why it won't let me put that in there. Okay, after doing some more exploring, I really did not find anything that should be keeping this fillet from going in. So I think it's just the inherent way that they have modeled this part. There's not a lot of room in here between the chamfer and the fillet, so that could possibly be a problem. It could also possibly be these strange intersections that they have up here and the way these parts kind of round together. It lets me put a fillet on this bottom section and on these side sections here, but it won't let me fillet this line. I can't even select it. I've tried, making small fillets and large fillets, and whatever I put in there, it won't even let me choose that. So something with the way that they've had us model this part doesn't allow it to go in there. I know they show it in the textbook, so I'll be interested to see if you guys can get it to work, if it's something I did wrong that I'm just not seeing, or if it really is another goof in the textbook. So they're not perfect, they do make mistakes, and occasionally they skip steps and forget to tell us how to do things. So again, remember, the important part of this project we're doing is not these fillets. These are very, very basic at this point. What we're trying to do here is see how to create parametric relationships between parts as we model them on the fly in an assembly file. So I've got basically the entire part modeled here. I am going to go ahead and add one more fillet in here that mine is actually letting me do. So I am going to add in this section as well, but the other ones keep giving me errors. So I'm just going to leave it at that right now and say that's probably good enough. And then I can hit the the back arrow here to go back to my assembly file. Okay, so there you can see we have the completed 2 pieces. And what they also tell you to do in the textbook at this point is you can try changing things and see how it affects the entire model. So for instance, if I was to go in and change this section, maybe I could change the sketch if I wanted to, and maybe where it says 3 here, I could change that to 3.5. And when I go back, theoretically this whole part updates. So not only does this part change, but this part changes. And the same thing would happen between these 2 phalanges. If I change this one would change. So that's kind of one of the neat things about these parts is if you change one thing, the other one should update to follow. And you can change it right back to its previous value if you want. Back out of your sketch, back out of your part, and now you're back here in the assembly file. So remember, you can actually model parts inside of assemblies, and there are some advantages and disadvantages to doing that. One advantage is you can see how the parts work together and actually see things on the fly as they're going to assemble, make sure things line up and match. A disadvantage is that it complicates the modeling process. So you have more things in your feature tree, you have more parts and features and sketches, and you got to keep track of stuff. So that's all we're going to do for this section. I know we're getting pretty long on the video here, so we're going to stop right there. And in our video next time, we're going to look at how do we take this and complete the assembly. So I'm going to give you guys the rest of the parts in our next video that you're missing. So we're not going to model every piece, but in the next one, I'll give you all these pieces that you're missing, and we're going to create the rest of this, which I'll show you what it looks like here. So we're going to take all those missing pieces, and here are the 2 pieces that we modeled. So we'll look at putting in the rest of these fasteners and all these different valve components, and we'll look at kind of how these go together or blow apart. So there's your exploded view, and then an assembled view would look like that. So in our next video, we'll look at kind of taking this and finishing it out. Okay, so that's it for this particular video. So give it a try on your own now and see if you can get these 2 parts built together as part of an assembly file. So make sure you upload any of the pieces for this. So notice when I save this, it gives them generic names. So you may want to come over here and rename these like we did the first time. So this one they're calling inlet housing. But again, they never told us to actually rename that where I see in the textbook. So make sure you go back and rename that and hit save all. So when you upload this file, you'll give me your assembly file and both of your part files. So you'll give me, in my case, water control valve assembly, outlet housing part, and inlet housing part. So you give me 3 files to upload it. So give it a try on your own. Hopefully it goes well. Hopefully it goes a little better than mine did, although I got most of it in there without too much trouble. So if you have any questions, you can email me, jhamilton83@ivtech.edu. You can track me down in class and ask me questions, or you can stop by my office, room T316 of the Technology Building. So good luck, and I'll see you in the next video.